Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 3 from section 7-7 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to factor a difference of two squares. So let's break down what that means before we get into any formulas. So when we talk about a difference, we're talking about subtraction. So we're subtracting two values that are perfect squares. And so here's kind of how it looks. Alright, I'm gonna be switching colors a bit, so I want to make sure that I'm kind of filling stuff in real quick. So notice I have squares and non-squares. So when I have a difference of squares, so when my perfect squares are being subtracted, I have two expressions being multiplied together that have the square root of whatever those squares are. One with a plus and one with a minus. Now this pattern is very, very, very important in mathematics. Alright, you're going to see it as something called conjugates when you have just the sign changed. And that's very important as we are dealing with trigonometry and other types of mathematics. So let's look at A and let's look at how to do this pattern. So notice on all of these really there's subtraction in each one. Now A, big A here, we have an x squared and a 3 squared because 9 is 3 squared. So when I go to fill this out, I'm following this pattern. So I'm going to put a plus and a minus. Now where that x is, I'm going to fill in an x and an x. And in the space where the 3 is, I'm going to fill in a 3 and a 3, and that's our factored form. Now the reason why this is important, I'm going to show you using the distributive property. I'm going to use the box method here. So I'm just going to re-multiply this stuff back out, right? Because factoring is just division. So when I do that, I have an x squared, 3x, negative 3x, and a negative 9. And so if you look at it closely, you can see right here the 3x and the negative 3x, they cancel each other out. That's why I'm left with just the x squared minus 9. Because the linear term there undoes itself. Okay, that's why this pattern is such a big deal. So now let's look at part B. So here 4x squared is the same thing as 2x squared. 81 is 9 squared. And they're being subtracted. That's how you know it's a difference of squares. So if I set up my double bubble with a plus and a minus, I'm going to fill in my 2x's at the front. And I'm going to fill in my 9 in the back. Alright, let's do that again. So x squared is x squared. And 64 is 8 squared. So I'm going to go ahead and set up my double bubble with a plus and a minus. I'm going to fill in that x in the first part and that 8 in the second part. So a couple of key things here. This formula only works when there's a minus between these. If there's a plus, you're going to get imaginary answers. Alright, and you guys aren't there yet. You guys haven't learned about imaginary stuff. So just be aware you have to have a minus in between these. And for you guys right now, these have to be perfect square numbers. Do they always have to be perfect squares? Not in Algebra 2. But in Algebra 1, you betcha, they're perfect squares. So on part B here, 9x squared I called 3x squared. And 100 was 10 squared. And they're subtracted with a minus, so they follow our pattern. So I set up my two sets of parentheses, one with plus, one with minus. My 3x went first, so it goes in the front of each parenthesis. And my 10 went second, so it goes in the back of each parenthesis. So there we have it, guys. That is how to factor a difference of two squares. Until next time.